and welcome to the Fuzzing 101 webinar on fuzzing performance. Our speaker today is Mr. Ari Takanen, the CTO of Codenomicon. My name is Ami Yuso and I will be the webinar organizer. If you have any questions, please send them to me through the chat window. All technical questions will be answered straight away. All questions relating to the webinar presentation will be answered at the end of the webinar in the questions and answers part. This webinar will last approximately 1 hour plus questions and answers. So, without further ado, I give the floor to you, Ari.
Thank you. And let's get started with the presentation. So the topic for today is fuzzing performance and parallel execution of fuzzing tools in general, and looking at how test execution can be speeded up using high-end hardware and such, and different options in especially Defensex toolkit. With that, quickly an introduction to the Fuzzing 101. So if you are not familiar with the series, you can download most of the earlier webcasts also online from our website. And we try to keep these vendor neutral, but of course many of the examples come from Codenomicon tools, which we've been developing and selling in the market since 2001. Very quickly about myself. My background comes from the academy, so I've been researching fuzzing and test automation since 1998. I managed to squeeze out a few books during that time as well. The one shown on the top right corner of the screen, which you hopefully see, is focused purely on fuzzing, and that actually has been written from the perspective of how you can use fuzzing and integrate fuzzing into your own testing processes. Today, what we'll be going through is looking in general what fuzzing is. For those of you who have not attended our webcasts before, this should give you enough information to be familiar of different fuzzing approaches and tools, and also what fuzzing is about. And then after that, we'll focus on the performance and parallel execution side of things. I will try to cover most of the areas in the slide set, which we'll also provide afterwards. So if you're interested, just drop us a note and we'll try to get it to you as soon as possible, but they will be available online afterwards as well. And hopefully, if the cards of demo allow, we will try to show most of those aspects in a live demo as well. Let's see how it goes today. So let's get started. In the fuzzing overview part, let's first look at what fuzzing really is about. So those of you who come from testing and quality assurance space are most probably very much familiar with feature and conformance tests and performance and load tests. Fuzz testing or robustness testing is completely different from these two, because features and performance typically focus on using valid protocol sequences and very typical use scenarios that you see in the network. On the other hand, fuzzing and robustness testing tries to explore all the unexpected events that happen in testing. Of course, like in this presentation, fuzzing has some similarity with both feature and performance testing, but the main focus is really in finding those unexpected message structures, message sequences, which cause crash level issues in software. And crash crashes can happen on any type of device, any type of application layer. So you can often see operating system panics or crashes, but quite often what you actually see is processes or even threads in the processes just exiting or dying. So you have to be very careful to be able to detect all these during the test execution. And especially with parallel tests happening, this becomes even more challenging, because you can imagine when you have like tens or hundreds of sessions going on at the same time, when something goes wrong, mapping those failures back to the test cases becomes much more challenging when you have parallel test execution processes happening. We've done a lot of tests, and based on our tests, it still seems that majority of both open source and commercial solutions have significant amount of crash level issues, and probably that just indicates that not everyone out there has started using fuzzing or are using wrong techniques of fuzzing in their product development. So definitely there's lots of work to do out there, and hopefully time will tell what these type of results will show in the future. Also, when you do testing, it's important to understand the different attack surfaces in devices. So for example, this example comes from wireless access points. So when you do fuzz testing, don't focus on just one layer of testing, but try to combine and try to test different types of test cases and different types, different layers of protocols. Maybe even in parallel, if you have high performance test platform that you use, then often you can reveal completely different sets of failures when you combine these tests together. But of course, most commonly, and the best practice in testing is not to really test that fast, but test sequentially and going through each one of these protocols one by one. After those, the first pass of tests has been done, then exploring more high-performance test setups can reveal a new set of failures that you missed in those single-pass tests. Really, the basic terms in product security and fuzzing can be maybe narrowed down to these few terms, which I won't go through in detail this time. But the basic understanding is really understanding that difference between vulnerabilities and attacks is whether your security solutions are actually focused on preventing attacks from entering your system or your code, or on the other hand, if you're actually looking for those bugs, individual bugs in code. So solutions that focus on finding vulnerabilities, known or unknown, try to find and fix the bugs themselves, and solutions that try to block or prevent threats or attacks are more reactive and focus actually on preventing those holes from being exploited. So of course, if you fix the hole, you will at the same time prevent all the attacks from taking place as well. Fuzzing, on the other hand, nowadays often uses model-based test approaches. That means that instead of using random testing, you actually use intelligent, smart, targeted tests where you go through all the different protocol capabilities and insert intelligent, optimized anomalies in order to find those failures and crashes.